Robotic Shield at Sea. How US Navy drones and military satellites are redefining naval warfare. Introduction. Imagine this. It is midnight in the middle of the ocean. The sea appears calm and empty. Suddenly, a hostile missile is launched hundreds of miles away. In the past, detecting and responding to this threat would have required a fleet of warships, aircraft, and hundreds of sailors. But today, the first responders might not be humans at all. Instead, autonomous drones floating on the ocean, unmanned aircraft patrolling the skies, and military satellites orbiting Earth instantly begin sharing data. Within seconds, the missile is detected, tracked, classified, and its trajectory predicted. Welcome to the age of the robotic shield at sea, a revolutionary military concept that is transforming naval warfare. In this video, we'll explore how US Navy drones work, their remarkable achievements, the critical role of military satellites, the military implications of this technology, and the valuable lessons India can learn from this rapidly evolving battlefield. Chapter 1. The Birth of the Robotic Shield. For centuries, naval power was measured by the number of battleships, aircraft carriers, and submarines a nation possessed. Today, that equation is changing. The US Navy is increasingly deploying autonomous systems that can operate without crews for weeks or even months. These include unmanned surface vehicles, USVs, unmanned underwater vehicles, UUVs, autonomous surveillance aircraft, artificial intelligence-enabled command systems. Together, they form what military strategists call a distributed sensing network, a vast web of sensors spread across the ocean. Think of it as a giant robotic shield covering thousands of square miles of sea. Instead of relying on a few expensive warships, the Navy can deploy hundreds of intelligent robotic assets that continuously monitor the battle space. Chapter 2. The US Navy's Robotic Warriors. Sea Hunter, the robot submarine hunter. One of the most impressive naval drones ever built is the Sea Hunter. This autonomous vessel can travel thousands of miles without a crew. Its mission? Finding enemy submarines. Submarines are among the deadliest weapons in modern warfare because they are difficult to detect. Sea Hunter uses advanced sonar and AI systems to track submarines continuously for days. What makes it revolutionary is cost. Operating a destroyer costs tens of thousands of dollars per day. Sea Hunter can perform many surveillance missions at a fraction of that cost. Sail Drone, the ocean's silent sentinel. Another remarkable system is the Sail Drone, powered primarily by wind and solar energy. It can remain at sea for months. These drones collect oceanographic data, weather information, maritime traffic intelligence, potential security threats. They act like persistent eyes and ears in remote regions where traditional naval assets would be expensive to maintain. MQ-4C Triton, the flying watchtower. While robotic vessels patrol the ocean surface, the MQ-4C Triton watches from above, flying at extremely high altitudes. Triton can monitor enormous stretches of ocean. It can detect ships, track suspicious vessels, support anti-submarine operations, provide real-time intelligence. Imagine having a surveillance tower thousands of feet in the sky that never gets tired. That's essentially what Triton provides. Chapter 3. Achievements of the Robotic Fleet. The achievements of US naval drones have been remarkable. These systems have demonstrated persistent surveillance. Autonomous platforms have remained operational for months, continuously gathering intelligence. Vast area coverage. Large ocean regions that previously required multiple warships can now be monitored by networks of drones. Reduced operational costs. Robotic systems significantly reduce fuel consumption, crew requirements, and maintenance costs. Enhanced situational awareness. By linking multiple sensors together, commanders receive a clearer picture of the battlefield. Human risk reduction. Dangerous reconnaissance missions can now be conducted without putting sailors in harm's way. The result is a force that is more efficient, more persistent, and often more difficult for adversaries to target. Chapter 4. The Invisible Hero, Military Satellites. Now comes the most important question. Who coordinates all these drones? The answer lies hundreds of miles above Earth. Military satellites are the backbone of the robotic shield. Without them, the entire system would struggle to function. Communication. Satellites connect drones, aircraft, ships, and command centers across vast distances. Navigation. GPS satellites provide precise positioning information. Without accurate navigation, autonomous operations would become extremely difficult. Surveillance. Space-based sensors monitor maritime activity, missile launches, and strategic movements. Targeting support. Satellites help identify threats and provide critical data for military planning. Modern warfare increasingly depends on information dominance. And information dominance begins in space. Military planners often say, the battle for the oceans may ultimately depend on who controls the space above them. Chapter 5. Military Implications for the Future. The robotic shield represents one of the biggest shifts in military history. Warfare becomes distributed. Instead of concentrating power in a few large warships, capability is spread across numerous autonomous platforms. Faster decision-making. AI systems can process enormous amounts of data in seconds. Greater survivability. Destroying one drone has little impact on the overall network. Lower costs. Nations can field larger surveillance networks without dramatically increasing defense budgets. However, new vulnerabilities emerge. Cyber warfare. Hackers may attempt to compromise autonomous systems. Electronic warfare. GPS jamming and signal interference can disrupt operations. Anti-satellite threats. If satellites are disabled, entire networks could be degraded. This means future wars will not be fought solely with missiles and ships. They will also be fought with algorithms, software, and electronic signals. Chapter 6. Lessons for India. For India, the rise of robotic naval warfare offers several critical lessons. India sits at the heart of the Indian Ocean region, one of the world's most strategically important maritime zones. Lesson 1. Invest in indigenous naval drones. India needs long-endurance surface and underwater drones capable of operating across vast maritime regions. Lesson 2. Strengthen military satellite networks. Space-based surveillance and secure communications will be essential for future naval dominance. Lesson 3. Develop AI-enabled command systems. The ability to rapidly analyze data and make decisions will provide a decisive advantage. Lesson 4. Create a hybrid fleet. The future is not humans versus machines. It is humans working alongside machines. Warships, submarines, drones, and satellites must operate as one integrated force. Lesson 5. Prioritize cybersecurity. A connected fleet is only as strong as its digital defenses. Protecting networks may become just as important as protecting ships. Conclusion. The robotic shield at sea is no longer a vision of the future. It is already taking shape. Autonomous drones patrol the oceans. AI systems analyze threats. Military satellites connect the entire network. Together, they are transforming naval warfare from a contest of ships and sailors into a contest of information, intelligence, and technology. The nations that successfully integrate the sea, the sky, and space into one seamless combat network will hold a decisive strategic advantage in the decades ahead. Because in the future, the most powerful naval weapon may not be the biggest warship. It may be the invisible robotic shield protecting an entire fleet.